All right, question number 12 wants us to use the graphing guidelines to make a complete graph of f. Now, a lot of what I will use in this video, just to kind of keep it simple, is some of the processes that we've learned in algebra. The easiest way to graph a function is to plot points. Plug in some values for x, evaluate them, and then get a y and plot some ordered pairs, and you can trace the shape. But I will go through a couple of the steps that you do need to know for sure, and I will refer you to the video. So because we have answer choices, we will be able to use some information, eliminate some graphs, and arrive at the correct graph sooner. But if you work a problem that does not have answer choices and you had to freehand or kind of piece it together using a different tool, this video goes into a lot more detail on all the steps. But for this video, I'm going to keep it simple and kind of show you how to get there a lot faster. One thing we will notice is we have a rational function, which means when we have a division, we have to figure out the domain because we cannot divide by 0. So I'll first focus on the domain. That will also tell us our vertical asymptote. So take whatever's on the bottom, 2x plus 1, and set it not equal to 0. Subtract 1. We get 2x cannot be equal to negative 1. Divide by 2. So we get x cannot be equal to negative 1/2 when we divide by 2. This number is not in the domain, so our domain can be every number except for 1/2. This also tells us that when graphing this, we would have a vertical asymptote at negative 1/2. So let's just say this is negative 1. Negative 1/2 would be here, and we would have a dotted line. So we draw the dotted line, but if you were to graph it, you wouldn't see a line. It would just be an imaginary line. So domain, any number except for negative 1/2, and then we have a vertical asymptote there. Also, we will check for horizontal asymptotes. Horizontal asymptote, there's 3 conditions. What we want to recall, if I'm going to put T, if the top is greater than the bottom, if the top is less than the bottom, or if the top is equal to the bottom. When I say top, I'm talking about the degree, the exponent. So we have a degree of 2 and a degree of 1. When the degree on the top is greater, there is no horizontal asymptote. HA is none. When the top degree on the top is less than the bottom, so let's say that this was 3 and this was like 5 or something like that, horizontal asymptote would be y equals 0. And when they're equal, it would be the ratio of the numbers. All right, in this case, the degree on the top is greater than the bottom. We do not have a horizontal asymptote. However, sometimes we do pick up a slant asymptote. A slant asymptote appears when the degree on the top is exactly 1 greater than the bottom. So 1 here and 2 here, so that's exactly 1 greater. We would need to do long division, and the top goes in, so I have x squared. Missing my single x term, so I'm going to put a 0 times x as a placeholder, and then plus 13. And then the 2x plus 1 on the outside. So we are looking at just the first term every time. We want to multiply the number so that we get 1. So 2 times something will give us 1. That will be times 1/2. You can think about dividing it by 2. So 2 divided by 2 will give us 1, or times 1/2. And then we have 1x. We need to match with this one to be x squared. So x times x. I need 1 additional x to get x squared. All right, once you come up with that term, whatever you need to multiply this term by to get it to equal this, we're going to distribute to both terms. So multiplying 1/2 x times 2x will give us x squared. 1/2 x times 1 will give us 1/2 x. And then you subtract, so this will become negative, this will become negative. Usually we say change signs. That will cancel out to 0. We'll bring down the negative 1/2 x, and then we bring down the next term, plus 13. And then we repeat the process. So this term and this term, I want them to be equal. So how do I multiply and turn 2 into a negative 1/2? Well, I do know I need a negative because it's positive right now. The only way I'm going to get a half is if I divide by double this number. So I need to divide by 4. So basically, I'm going to multiply by 1/4 because 2 over 4 reduces to 1/2. That'll match that. So that'll give me a negative 1/2. It's 1x and there's 1x. So all I need is a negative 1/4. Now at this point, we are done. We don't have to continue. I just need the linear expression. So my slant asymptote, because we don't have a horizontal, we have a slant now, is the equation y equals, and it's going to be 1/2 x minus 1/4. So if I was to plot that on this same coordinate grid, I would start at, let's say this is -1, negative 1/4 would be about right here. And then I would make 1 point for my slant asymptote, and then I would follow my slope. So go up 1 and right 2. So if I could draw this according to the line, it would be something like this. Slope of 1/2. It'd be a slant asymptote. Now you can cross a slant asymptote, horizontal, but not a vertical. All right, so these would be my asymptotes. I could use these two lines and kind of eliminate some graphs. So I would definitely eliminate this one. It's going the wrong direction. So I would get rid of A and D. So I have a 50-50 shot. Now doing the derivative, second derivative will take a lot more time, especially with critical points, since we have to do quotient rule. It's not impossible, but it just takes a little bit of time. So the best way to pick out the correct answer is we're going to plot some points. So choosing between B and C, because they have the correct direction on the asymptotes, all we have to do is pick a number. So let's say if I was to pick 2, 4, 6, 8, 10, so these are counted by 2. Let's just say if I pick 4, well, those both work. Either I'm going to get a positive value, which will correspond to B, or I will get a negative value, which will correspond. That one still could be positive. 2, 4. That one looks close to 0. But either I'm going to look for something positive, like above 2, or I'm going to look for something that's really small, possibly negative, because this is the x-axis, this is 2, this is 4. Let me zoom in and see it a little bit closer. So at 4, we're going to be really, really small, positive, versus the other graph, B, at 2, 4, we're at 2, something greater than 2. All right, so that's going to be our test. We're going to plug in 2. I'm going to say f of 2, just plot 1 point. It's going to give me 2 squared plus 13 over 2 times 2 plus 1. 2 squared is 4 plus 13 gives me 17. 2 times 2 is 4 plus 1 is 5. Okay, so if we just approximate, 5 goes into 17 3 times, so this is about 3 point something, 3.4 roughly, and that looks closer to graph B, so we can conclude it's B. Now I didn't even do first, second derivative, concavity test, increasing and decreasing intervals. Those are explained here, and I'll let you go into a little more research if you wanted to freehand it all and match it up that way. So let's check it. And it says good.